welcome everybody for joining us today. My name is Tim Cook, and I will be your moderator today, as Brenda is currently out of the office. So give me a little bit of grace, as I'm not the normal one to run these things, but hopefully everything will go smoothly. Today's webinar is focusing on event-related electrothermal activity and the stimulus presentation software within AcqKnowledge. So the nice thing about that is that it is a built-in licensed add-on to AcqKnowledge, which is available to anybody running AcqKnowledge. Announcing a call for proposals. This recently opened on November 4th. So an email was sent out, but if for some reason you didn't receive that or aren't privy to that, you can learn more by either clicking the links on this slide, or clicking these links, and again, we can share these slides with you after the fact, or you can quickly click on the QR code to get additional information. The goal of this is to invite researchers to advance multimodal brain research. There will be one grant, but several academic partners can apply as a team. The winner or winning team will be granted a temporary loan of all the equipment needed to complete a brain-body experiment using both the MetalOpt Plus, the MetalOpt Plus FNIRS system and an MP200 system with whatever amplifiers or modules are required for your project. So again, if that's of interest to you, definitely feel free to, again, scan the QR code, click on the links, and reach out to us with any additional questions. But we are hoping for a good number of proposals that we can go through, and look forward to giving that award. Now, on to our presenter. Fraser Findlay is the CEO of BIOPAC. He has over 25 years of experience in the life sciences and physiology monitoring industry. He is a well-regarded expert who presents workshops in Europe, Asia, and the US. Welcome, Fraser.
Welcome, Tim. Welcome, everyone. Thank you for joining. Thank you. Perfect. All right. Well, welcome, everyone. Thank you for the introduction, Tim. As Tim mentioned, this webinar is all about event-related electrodermal activity. We're going to cover a lot of ground. This is kind of a follow-on from the previous webinar. So parts of the material that I'm going to go through today, I'm going to jump through quite quickly. So if you want to sort of get some deeper information and better insights, I recommend taking a look at the last webinar as well, which was more on general EDA recording and setup. But before we dig into the EDA side of things and the event-related tasks, I've got a little background information about BIOPAC. BIOPAC Systems, Inc. is a global leader in life science research solutions, empowering scientists to measure physiology anytime, anywhere, and from any subject. BIOPAC has been advancing research for over 30 years, with its cutting-edge tools and software trusted by 99 of the top 100 universities worldwide. With more than 56,000 scientific citations, BIOPAC's technology is relied upon by leading tech companies for product development, validation, and human-centered design. Okay, so when we talk about the experiment, we're really talking about the stimulus presentation side of things. So this is BIOPAC's language. And the type of presentation that's being delivered to the participant. AcqKnowledge software has a built-in stimulus presentation system that will interface automatically with your data acquisition system, with eye tracking if you're doing that, if you have a license for face reader, and then other forms of stimulation, whether that be olfactory, thermal, electrical. All of that is fully integrated within the AcqKnowledge software. Now, as Tim mentioned, the stimulus presentation system, it is a licensed feature, but it's really straightforward to use and it's easy to operate. The big advantage being a single technician can manage the entire workflow from a single computer with a single user interface. Excuse me, and we'll get into that in a little bit more detail. But BIOPAC also integrates with ePrime, where digital triggers can be sent from the Chronos device, and those event marks are sent to the STP100D, or perhaps you may have the STP100C. That's it's an isolation module. So when we're connecting third-party devices that have their own power supply, we need to make sure that we're isolating the participant. So the event marks come into the STP100D and they show up in AcqKnowledge. So you run ePrime just as you would normally. As an image is presented, an event mark is sent to the STP100D, and then that becomes part of the record, part of the recording in AcqKnowledge, along with any physiological signals that you may be recording. There's also an option to deliver stimulus presentations in MRI. So again, ePrime will be presenting the images, but in addition to that, we have this tool that allows ePrime to trigger electrical stimulation. So this can be taking place while the participant is in the scanner. Another one of our partners is Superlab. And the latest version of the Superlab X6 enables you to sort of minimize the hardware integration. The Superlab X6 uses our network data NDT, network data transfer protocol, whereby event marks are sent electronically across the network, and then again they become part of the recording. So that's the latest version of Superlab X6. They also have hardware devices that work in essence similar to the ePrime device, whereby the signals, the triggers coming from the Superlab hardware connect to the STP100D. And in this image, I'm showing the back side of the STP100D. These connectors here, the ribbon cable connects between the device and this connector. And then all of that data is collected with the physiological signals, and then you can use it for further analysis. So that kind of gives you a little bit of information about what we're considering when we're talking about the experiment and stimulus presentation. I'm going to give you a quick show and tell, and bear with me while I get organized here. Change my display, so bear with me. Okay, good. All right, so this is one of our sample files in AcqKnowledge. Let me minimize some things here. Make it easier for you to see. All right, perfect. So on the left-hand side, this is the physiological data. On the right-hand side, this is the stimulus presentation. And this actual file was used in conjunction with eye tracking as well. I'm not going to go into details on that, but when you click in the physiological recording, it will advance the display on the right to show you where the participant was looking. But this is the presentation that was delivered to the participant. Now, there are some key points that I want to make before we get into that. AcqKnowledge has a global event bar along the top. And these events here are marking the entry and exit point of an area of interest. But if I scroll along a little ways, eventually we will get to something like this light bulb. This light bulb is the icon associated with an image that was presented to the participant. And you can see it's got a label on it. So if I click after that label, you can see this image was presented at this point in the recording. So then we can look at the physiological data and we can take measurements around that. So that kind of gives you a quick introduction of what you can expect to see in the next section. For now, I'm going to hand you back over to Tim for our first poll of the day.
Perfect. Thank you, Fraser.
Sure.
So the first poll is, do you currently have a stimulus presentation platform that you use? Be that the BIOPAC stimulus presentation, ePrime, SuperLab, virtual reality, or other, which can encompass PsychoPie, Media Lab, et cetera, et cetera. Give it a couple more seconds. Looks like other is actually winning out a little bit. Still got a couple votes coming in. It's actually good to see a good handful of you are actually using the BIOPAC Stim presentation too, so that hopefully this will be beneficial with Fraser going through this a little bit more. Okay, I will end the poll and share the results so everybody can see them. That's, like I said, right now it's kind of between other and ePrime is the biggest between those two. So, all right, I will close that down. You're good to go on, Fraser, and your screen looks good.
Okay, awesome. Thank you. Thanks everyone for participating in our poll. So, okay, so where we left off, I had just shown you how the importance of the events are within the physiological data and how they help to tie everything together. The flip side of that is, how do we create a stimulus presentation? Now, if you have the stimulus presentation license, when you launch AcqKnowledge right at the beginning, there is an option there to open an existing stimulus presentation or to create a new one. This is the stimulus presentation that related to the previous section. Over on the left, the way this user interface works is broken into three primary areas. On the left, you have the stimuli that you want to present. In the center, you have an editor, visual editor, so it displays the image the way it will appear on the screen for the participant. And then over on the right, you have the properties that are associated with this image. And to start off with, you can just grab of any combination of images, video, audio, all the way down to controlling one of our stimulators. You can sort of add all of those different types of stimuli. All you're doing at this point is bringing them in and setting the properties. Now, if we look at the properties, the first thing you have the name, that's just the name associated with, in this case, the image. Then you can categorize them. The categories become really useful if you want to randomize the way images are presented. You could have positive, negative, neutral, or you can create your own categories. So if you label this as, maybe a neutral type image, a picture of a building, you could have a library of 10 different neutral images, 10 positive, 10 negative. And then when you use random as one of your choices and bring that in, add random, you can then pick from your categories and you can say, okay, I want to present a random, I don't have any in there, that's what it's telling me. You can create a random positive image that's going to be presented, okay? And then if you decide that you want to eliminate that image or not use it, that's all controlled over here within the sequence. The sequence is the order in which the stimuli will be presented to the participant. So initially, we're basically controlling everything, making sure it's labeled correctly, making sure that if we're categorizing it, we've got the correct category. We can control the background color of the images. So sometimes you don't want to have a stark contrast between an image or text and the background. So here you can come in and you can pick whatever color you want. You've got controls for scaling of the image. So sometimes, not sometimes, you typically want to make sure that the image that's presented to the participant is scaled appropriately rather than stretched one way or the other. And you can maintain the aspect ratio as well as scaling it to fit the monitor. Now, something up here, we have this sync output. By default, that's always enabled. AcqKnowledge will always mark the occurrence of a stimuli as it's presented during the experiment. But you can determine what type of an event mark you use. And over here within AcqKnowledge, there's a whole slew of them. Stimulus delivery is the one that we default to. It's the one we recommend. That's the little light bulb that I showed you earlier. But if some reason you want to use something different, you can pick from any of the different event marks, including something like a star or a flag. It's up to you, but the default will be stimulus delivery. Then as far as your sequence is concerned, all your images in your library that you've loaded up will appear on the right-hand side, and then you can either drag them over or just here, you can see there's a little arrow to the left that will move that item in. And then if you want to change the sequence, you've got controls at the bottom down here. So you can move things up the list or move them down. Or if you want to remove them, you can just hit the X and that will take them out. Now that doesn't mean that it's deleted them, it's still within the available group, and then you can just move that back over and it will automatically drop it to the bottom of the list. So this toolbar here is really all the controls that you have. The little kind of ironic, the disk icon is the save icon. This one here is dry run. This is super helpful. This will allow you to run through your presentation, and I've got it actually playing on the other monitor, which isn't the other display, which isn't very helpful for you. But it will run through similar to PowerPoint. It's just going to present the images, the sounds, etc., etc. The red circle, this is recording, so this will start the entire experiment. And there's a little bit more to this than meets the eye, and I'll get into that in a moment. When you're under the stimuli section. The plus allows you to add new stimuli. So you can't add new from the sequence. All you can do is control the sequence of your different stimuli. Now this tab on the right, I'll get to in a moment, but this allows us to set up our hardware. Finally, the last one, this Sigma icon, if you click on that, move that over. This gives you a really nice summary of everything that is going to occur within your presentation, including the timelines. And then you can copy that to the clipboard and you can paste that into a journal file, or keep a record of it somewhere for your experiment. So this is sort of summarizes everything. There's a total of 9 events that are going to occur, and this has a total duration of 377 seconds. Okay, now the last tab, this is the data recording. This is where you control the data acquisition system that you're using. Now, in my case, I've got an MP200 set up, but I can come in here and I can use an existing graph template. So if you're familiar with AcqKnowledge, you can just open up a template with all your channels set up, or you can go in and edit the current setup. So here, this is that familiar dialog box that you get to for setting up data acquisition. If you've got any of our smart amplifiers, you can plug those in. If you're using any of the bioinformatics modules, you can come down, select the item that you're interested in, and now we'll run through the calibration. Continue. We're ready to go. Now, some of you may have run into this with EDA. If you do an initial calibration and you leave this checkbox enabled, every time you run the experiment or hit start, the system will want to recalibrate. If you just remove this checkbox here, because we've already gone through and done our scaling, the system won't prompt us again. When we hit close, that's the hardware setup. You can select the monitor that will be used, because this is typically done with 2 monitors. It's a little bit like the way PowerPoint works. You have sort of the presenters mode. That's one monitor, and that will be the technician. Then the second monitor, you will have just the stimuli being presented to the participants, so they don't see anything else other than the images that are being presented to them at the appropriate time. If you are doing eye tracking and you've got an eye tracker connected, this box becomes active. I don't have an eye tracker connected, but otherwise you could enable that, and then you can create areas of interest. So this has already been done for this experiment. So you can see these areas, regions have been identified as areas of interest. Then as the participant looks at this region here, the software will automatically record the entry, the duration, the exit time, the number of fixations while they were looking at this area of interest. And then if you have a face reader license, you can enable face reader, and then providing you've got a webcam looking back at the participant, the system will record the facial expressions while the subject is receiving the stimuli. So setup is pretty straightforward. You've got your sequence determined, you've got your hardware and everything connected. You know the stimuli that you're running, you've checked your summary to make sure you've got everything organized. At this point, all you do is hit record, and then the presentation will begin. And then, as I said, there are 2 modes. One of them is the images that are being presented to the participant. That will happen on whichever monitor you've selected. The other side is the technician will see the physiological data being recorded and the event marks being dropped into the recording. So it's pretty straightforward to get this organized and set up. And as I've mentioned before, one technician can run this single-handedly. You're only using one user interface. Everything you need to control the equipment and the software and the stimulation is all managed through this user interface. So just to give quickly. All right, so this will run and you'll see the physiological data being collected simultaneously with the event marks coming in like so. At this point, I'm going to hand you back over to Tim for our next poll.
Perfect. Thanks again, Fraser.
Sure.
Okay, so in what use cases are you currently interested in? Are you looking to collect data from single subjects, potentially dyads, larger groups potentially, or long-term? And obviously, as we're looking for, this webinar is covering event-related type stuff, and as you move away from single subjects or potentially dyads and get into the group type stuff or longer term stuff, the event-related probably does become more challenging. There can be ways to do it, but it's probably something you're going to have to give additional thought to in terms of how to mark specific events within data. But that's something we're always happy to talk through and see if there's solutions for as well. So looks like voting has stopped, so I'll share that really quick. So it looks like the vast majority are dealing with single subjects. I'm kind of surprised to see that group actually outperforms dyads, so that's kind of interesting. Close that down. Again, that was quick, but back to you, Fraser. And again, your screen looks good.
Perfect. I'm just going to change my screen back over, so bear with me. Okay, so what I'm going to do now is talk a little bit about the hardware and software. Well, we've already done the software, but hardware and the subject setup. Many of you have, different types of scenarios. So I'm going to jump through these reasonably quickly so that we can get into more of the analysis and the software. If you want more details on this stuff, as I mentioned previously, the last webinar goes into this in much more detail. But if you've got the MP200 system, this is pretty much our core research platform. It replaced the MP160 and prior to that, the MP150. There are two primary amplifier types that you can choose, either wireless or wired. And dependent upon the generation of equipment you have, this is the latest D series amplifier. It's super small. This connects to the participant. It uses the same electrode leads that we use for the bioinomatics, for the wireless stuff. So it's really It's lightweight, it's super convenient, it's easy for the participant. And when you plug these devices into the AMI module on the MP200, the software immediately recognizes that you've connected an EDA device, and it sets the scaling and everything up for you. If you've got the previous generation, we still offer these. This is the C series amplifier. These been around for a long time, kind of bulletproof. The one thing you have to pay attention to, and I will mention this, I've got a red ring drawn around it. It's important that you have these switches both set to DC. That enables us to record the tonic waveform or skin conductance level. If you have one of these switches in the high pass filter position, you'll run into problems where you never get the absolute skin conductance level. That signal will drift down. So if you're using one of these amplifiers and you're constantly seeing your signal drifting down, 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 double check this. Okay, now the signal will drift down as a person relaxes, but that's a little different. So key point there, make sure that you've got those set to DC. If you're interested in having a little bit more flexibility for your participants, so maybe they need to be moving around while they're performing a task, the wireless bioinomatics modules are super convenient. This particular unit shown here is for electrodermal activity and pulse. So from one hand, you'll get both signals. You can get approximately 10 meters distance from the participant back to the receiving module. The receiving module is this one here. This module here is the receiver. And you kind of need to be line of sight. So you want to avoid obstacles and things like that, because that will help improve the performance. And then the bioinomatics also comes with different options. Instead of using an MP200, if you're going out into the field and you want to record data from, maybe participants in their home or in a workplace, and you don't want to lug around a lot of equipment, this is a great way of doing it. This is a smart center. It fits in the palm of your hand, super convenient. You can connect 3 bioinomatics transmitters to the one receiver module. This connects to your computer via USB, and then you get the same 10-meter line of sight. But the advantage is super small, it fits in a little carry case. So if you have a laptop computer in this carry case, you've in essence got your lab on the road. If you're interested in collecting data remotely for long time periods, we also have the bioinomatics logger. So the transmitters can talk to the logger, they can talk to the smart center, or they can talk to one of the receivers, which I showed previously. The logger has an accelerometer built into it, so you also get the activity from the participant. It also has a voice journal, so the participant can keep a record of anything that's significant. They can mark events. And again, you can have 3 bioinomatics transmitters talking to the one receiver. You also have the MP36, which is a 4-channel unit, pretty straightforward. Universal amplifiers. As long as you don't need more than 4 channels, it's perfect. Here you've got the choice of reusable or disposable. That's the same with the other units as well. We recommend the use of disposables. Get better long-term results. Problem is with the reusables, they do tend to degrade and you don't notice it. It's not abundantly obvious early on. With the disposables, you get a brand new electrode every time. Then if any of you are doing MRI, we have full solutions for MRI. All the equipment goes in the control room, participants in the chamber, and then we have a patch panel filter, and then 2 cables, one from the amplifier to the filter on the patch panel. And then on the chamber side, we have an 8-meter cable that runs to the bed, and then we connect electrode leads and electrodes, and these are carbon fiber. If you've got questions about this, talk to our sales team or our support team, and they can give you guidance there. Finally, the last piece of equipment we offer for electrodermal is the ring. The ring is very, very convenient. The form factor is great for those use cases where you just need the participant to be out and about. It collects a number of channels of data. You get EDA, you get pulse, temperature. You've got an IMU that will give you accelerometry, X, Y, and Z. And now you can get continuous ECG on there as well. All of that talks to an app on the phone, and then that data can be pushed to a cloud. And then if you're using it in lab, the ring can talk directly to AcqKnowledge, so then it just behaves the same as any of our other devices. Okay, just wanted to throw this in there. I had this in from the previous webinar. We've got a really nice guide that you can download for our website. There's a QR code that I've put in down here, or the URL is just there. Super convenient, gives you all the lowdown on recording, setup, things you'll find helpful if EDA is important to your research. Okay, so setting up the participant, it's pretty straightforward. You need the electrodes. As I said, we recommend the disposables. These are now dry, and not meaning that they're dry, you don't need to apply gel to the electrode, because you do. They're just dry in the package. And that is super convenient, because if you're a little bit relaxed about how you keep your electrodes, they'll never dry up, because until you're about to apply the electrode to the participant, you don't need to add any gel. When you're adding gel to the electrode, it's just a pea-sized amount of gel just on the sponge just here. Apply it to the participant. And oh, I should mention, you need to use isotonic gel. We offer gel 101A. It's isotonic, it conforms to the standards for electrodermal recordings. And this is super important. Do not use regular gel. Make sure that you are using an isotonic gel. Okay, in terms of electrode placement, this comes up a lot. This is probably one of the #1 questions when people first start. Typical, most common placement of electrodes, the fingers or the palms. Advantage being super convenient to apply the electrodes. It's, minimally invasive with a participant. The downside is if the participant is performing a task, you end up with artifact, and that can be a little bit annoying. And that's where you get to the next point. If you are using your hands, what can you do? There's a whole bunch of other places that you can collect electrodermal activity from. Some locations are better than others. There's a publication which I've referenced here that provides information on the different sites, the levels that you can expect to record. So just kind of some tips. When the participant comes in the lab, just wash their hands with water, just clean off any oils, make sure they're thoroughly dry. We don't recommend using soap at this point. Make sure the room that you're recording the data from has a comfortable ambient temperature. You don't want it to be too hot, and you certainly don't want it to be too cold. Determine the best hand to use if using the hands. So if the participant is right dominant and they're using a mouse, then you probably want to use the left hand and vice versa. If they're using both hands, then maybe consider an alternate location. Pea-sized amount of gel to the electrode sponge, fill the cavity if you're using the reusable electrodes. You don't want to have air gaps in there when you apply it, but we strongly recommend the disposables. Apply the electrodes and make sure they're secure. We recommend also taping down the electrode leads. That sort of helps mitigate the electrode lead getting caught on something. Also, if the electrode leads are loose, they can bang around and that will introduce artifact. So just a little piece of surgical tape, place it on the electrode lead to secure it. Once the electrodes have been applied to the participant, you want to let them settle for about 5 minutes, between 5 and 10. So what we recommend when the participants first come in, get on with applying the electrodes as soon as you can, because by the time you get to the recording segment, the electrodes have already been on the participant 5 to 10 minutes, and then you don't have to wait any time longer. But if the last thing you do before recording is apply the electrodes, then you're going to have to wait for 5 minutes. The reason for waiting is it allows the gel to penetrate the skin, and then you reduce those impedances and you get cleaner, better signals. For the eagle-eyed QR code on the right, we've got an FAQ section on the website which will go through many of your questions and answers. So the guide and the frequently asked questions form will provide you with an arsenal of information that I'm sure many of you will find helpful. All right, I'm going to hand back over to Tim for our third poll.
Perfect. Bring this up here quickly. Okay, so in what environment are you currently or looking to record your data? And I'm guessing the majority will be in the lab. We obviously see that a lot more. That looks to be the case. We'll give it a couple more seconds here for a few more votes to come in. Perfect. That looks like it's pretty much stocked. And yeah, that does kind of fall suit with what I was thinking. The vast majority are in the lab with stationary subjects. So that probably is the easiest scenario for everybody to deal with. Perfect. So that's actually our last poll. We'll close that down. And back to you, Fraser, for
Perfect. Thanks, Tim. Again, thanks everyone for participating in our poll. I'm going to change monitors again, so bear with me while I switch over. Great. Okay, so what I'm going to do now is walk you through, and actually I've got a couple of slides. Swap this over. Okay, so what I'm going to do now is walk you through the analysis portion. We kind of went through participant setup. I showed you how to create a stimulus presentation, set up the hardware. Now we're going to get into the fun part, which is, we've recorded our data. What are we going to do? Now, AcqKnowledge comes with a whole slew of tools for taking measurements and being able to extract information. I'm going to walk you through how we would do that with a typical recording. And then finally, a lot of the things that I'm going to show you today can be fully automated through workflow. And if you're not familiar with workflow, workflow basically allows you to create a sequence of events that you would normally manually go through, but it creates this automation. So let's say you want to apply a filter, you want to run one of our analysis routines across it. Rather than going through the individual steps to do that, the workflow will automate that. There's no programming, it's drag and drop. We've run some webinars on this, and it's super helpful for speeding up your analysis, and then not only speeding it up, but also ensuring that you're getting that consistency. So everyone in the lab is performing the analysis the same way you do, or more importantly, you perform the same tasks and in the same manner across every single participant file that you touch. So anyway, that's workflow. Let's take a look at how we would analyze some of the data. If you want to follow along with this, you can. I'm trying to use the sample files as much as possible because you will have access to those in AcqKnowledge as well. This file is SCR with events. If you come into the file menu, there's the open sample data file. You will find this file in there. Along the top, we see the event marks that came in from AcqKnowledge. Down below, I've got a single channel. This is skin conductance level data. This is the tonic waveform. This sample file was recorded at 10 Hertz, so low sample rate. There's a couple of things that we always recommend. I mean, this is one of our sample files, so it's pretty clean. There's no real artifact in there. But normally what we would do is we would resample it because our default sample rate, unless you've adjusted that, is 2,000 samples a second. So you come in, there's an option here, resample waveform, and then you can resample it down to a lower number from 2,000. The next thing we do is we run a median smoothing, and the smoothing is here. And you need to make sure that you select median, and this data is sampled at 10 samples a second. So I'm going to run a median smoothing over 10 seconds. What that will do, that will eliminate any transient spikes that may occur in your data. It's really a powerful tool for doing that. It doesn't do anything to the data. It's really not going to have any effect on here because there are none of those spikes. So I'm just going to ignore that. But just giving you the recipe for what we would typically do. And then we come in here and we usually run a low pass filter. And I run a low pass filter. This is an FIR, and it's going to be 1 Hertz. Before I do that, I'm going to select all my data, Control A. Let's go back in, low pass, 1 Hertz, and then we've now filtered that waveform. You can see the scaling over here. This is in microsiemens we're looking at on the right, and then this is the entire recording. If I click on any of these icons, you can see the label that was applied. This was not very imaginative. There are 2 types, type 1 and type 2. You can get a better look at that if I open the event marker palette. So stimulus delivery, the label 12112. Now, AcqKnowledge has an automated routine that, if I come into electrodermal activity, oops, if I could control my mouse, event-related EDA right here, this opens up a kind of scary looking dialogue, but if you just walk your way through it from top to bottom, it's actually pretty straightforward. The first thing you need to do is pick the tonic channel. Now there are other channels in this file. I'm just showing the one that's relevant. So channel 1 is labeled EDA. So this is the signal that we're looking at in the background. The software will construct the phasic signal. Now the phasic signal is important because that's the signal that we're going to use to identify skin conductance responses. And I'll come into that in a moment, get in a little more detail. So I'm going to construct a new phasic waveform. My stimulus events are the default from the stimulus presentation, which is stimulus delivery. But again, that same list that I showed you earlier is available. So if you decided to use something else, you can pick that event type. The events are located in the global events bar. This bar along the top is called the global events bar. Okay, so I'm using that. Now this is the important point here. The software, this analysis routine, will identify all the skin conductance responses, but it will also identify what we refer to as specific skin conductance responses. So a specific skin conductance response is one that you can tie to a stimulus event that occurred. But if the skin conductance response starts inside 1 second after the stimulus was presented, that's non-physiological for a skin conductance response, so it will be ignored. The window is between 1 and 4 seconds. So as long as the skin conductance response starts to occur in that window, the software will identify it as a specific skin conductance response and mark it accordingly. Then you can, this is sort of the way in which the data is displayed, but we spit it out into Excel, so you can slice and dice that any way you want. The next option, you can get a summary based on a time window. So in this case, I've got it set to 20 seconds. So the software will run through 20-second epochs, and it will give you the number of specific versus non-specific skin conductance responses that occurred within that time window. So you could make that, you know, a minute, 5 minutes, and then it will give you the summary over that time. And then down at the bottom, it will output the events for specific skin conductance responses, and it will give you the ratio of occurrence for the different image categories. Now remember, in this file here, there are 2 image types, image 1 and image 2. And then I want my results output to a spreadsheet. Okay, so the software's gone through and performed the analysis. And if you look, you can see we've got these blue water drops. These mark the occurrence of a skin conductance response, or the peak of a skin conductance response. That skin conductance response was identified using the phasic waveform. Okay, now I told you I would come back to this in a little bit more detail. If we look closely at the analysis, you can see a skin conductance response is made up of 3 events. On the left-hand side, you've got an opening parentheses, you've got the skin conductance water drop marking the peak, and then you've got the close. This is when the signal crossed the threshold, and I'll show you the threshold. So the signal right here, this is crossing my threshold. If we come into the analysis, under electrodermal, we've got preferences here. The threshold was set to 0.02. So that means that at this point, the phasic signal crossed point O2, and that marks the onset of the skin conductance response. If I come back in and we compress this down, if you look closely, you can see we've got some additional water drops being displayed. These are marking specific skin conductance responses, and they tell the type of skin conductance response that was that initiated this particular specific response. If I come over to Excel, this is the summary of the analysis we just ran. The software identified 4 specific skin conductance responses. It gives you the time, it gives you the level of the skin conductance level, the latency. So this has to be within our window. So 1.8 seconds, 4 seconds, 3.7. This is the onset. The skin conductance response amplitude, the skin conductance rise time, the size, the onset, and then the stimulus type. Okay, so if you add the amplitude to the onset time, you get the skin conductance response time. And then down below, these are all the unmatched stimuli. So these images were presented, but the participant didn't respond or did not meet the criteria for a specific skin conductance response. And this is our 20-second binning of the data, and you can change that to any time window you want. We get the number of specifics versus the non-specifics, 20 seconds, and then if you want, you can add epoch labels in there as well. Down below, we give you the matched summary. So here, this is for stimulus type 1. You've got the amplitude and the magnitude of the response. You've got the number of matches, so the number of specific skin conductance responses for stimulus type 1, the number of non-matched. You get the total that were delivered, so 8 and 3 is 11, your total. Then it gives you the frequency of specific skin conductance responses. So that's for event type 1. Event type 2, you get the same information. Okay, now there's some other things that you can do using the software. I'll quickly show you. Obviously, AcqKnowledge allows you just to come along and arbitrarily you can select a period of data and you can get the mean skin conductance response, for example. So for this time period, we're measuring 7.3. I can come over and say, okay, really what I care about is the number of events, and I'm going to select skin conductance response. And now, just by selecting this area, it will tell me I've got 8 skin conductance responses within the window. Now, the other thing we can do is I can highlight an area of data like so, and I can create a focus area. Focus areas are really, really convenient. I'm just going to quickly create one here. One for baseline, and another one over here, and we'll just call this test. Now, if I come into actually, if I use my zapper, I can just get rid of all the analysis, and I'm just going to do this same again. So I'm back into event related, same dialogue. But down the bottom, instead of analyzing the entire graph, I'm just going to analyze within the focus areas. And I'm going to use the phasic waveform that I've already got on display, channel 5, and I'm going to hit OK. All right, so now in my spreadsheet, down the bottom, you'll notice we've got baseline and test. These are the results for the 2 focus areas. And you can have as many focus areas as you want, and you can create the focus areas during your data collection. So the focus areas are controlled under event marking, and we can set those so that they'll, when you hit F1 or F2, so let's just say I make F1, I'm going to create a focus area. I can pre-label it baseline. So when we're recording our data, I hit F1, that starts, that opens the focus area. When I hit F1 again, it will close it. Maybe F2 is for a test period, so on and so forth. Then at the end, you're completely ready to start your analysis. Now, I know we're a little bit long on time. There's one other thing I wanted to mention. If I come in, there's a tool in here. It's called epoch analysis. And I'm going to find events, and I'm just going to locate specific skin conductance responses. And I've got a 5-second time window. And I'm just going to look for 5 seconds after a specific skin conductance response. I'm going to output my measures into Excel, and I'm going to choose the maximum skin conductance level, the mean skin conductance, and the minimum skin conductance within that 5-second window after a specific skin conductance response. And I can add another one, let's just say the peak to peak. So, and that will be on EDA. So now we've got these different measures. I hit OK, and that data is now output to Excel. I've got the maximum, the mean, the minimum, and the peak to peak for those 5-second epochs around just these specific skin conductance responses. There's plenty of other tools that you can use as well, but it gives you a sort of a quick run through setting that up. And I know we're a few minutes late, so I'm going to hand you back over to Tim.
Perfect. So basically, I'll open it up for a little bit of Q&A for a couple of minutes, if anybody, for those who want to stick around. We actually have received a bunch of questions, most of which I've gotten to, a couple that might kind of be good to address to the group. One person asked, in the case of waveform onset, let me get back, let me make sure this is the initial one. Yeah, it says in the case of waveform onset being before the Stim event, we manually shift it to immediately after the Stim event. In this case, is the SCR latency a valid data point? And I had, you can see if you have anything to add to this, Fraser, I had basically said that I don't know if that'd be a methodologically sound in order to manipulate the data that way. I mean, because technically, if you have a response occurring before your event, to then shift your data up to a second to that it shows it occurring after the event, it really isn't a true representation of the data, and anything that occurs outside of the event being presented, whether it's prior to the event being presented or outside the 1 to 4 second window, would be seen as a non-specific response as opposed to specific response.
Yeah, I mean, that's the real issue here. I mean, if you really care about specific skin conductance responses, you have to pay attention to the onset of the skin conductance response and not the peak of the response, because the participant is beginning to respond to something that happened before the event was delivered. So that would invalidate it from being a specific skin conductance response. That could be a spontaneous response, or it could be a lag from a previous event. And this brings up another point, which is the timing of your presentation. Your timing of your stimuli has to account for this time window. Otherwise, you end up with overlapping responses. So if you're presenting an image and you really care about it, measuring event related and looking for specific responses, you've got to make sure that image is on screen for at least the time window that we're talking about. So it should be, really greater than 5 in that 5 to 10 second period in order for the participant to see the image and then start to respond, and then you start to see that recovery before the next image or the next stimulus is presented. So I agree with you, Tim. If you're moving the onset, then that is not a true specific skin conductance response.
Okay. And then for those that are looking to potentially look at responses over a longer period of time, to get an SCR count, things like that. Again, I had mentioned on that one that if you're trying to look at anything outside of that 1 to 4 second window, and if you're looking at overall skin conductance level, basically, for something, for an event that falls, again, looking outside 1 to 4 second window for 20 to 30 seconds, you really can't do a count number of SCRs, but you really at that point kind of have to look at the overall gross skin conductance level compared to baseline, because to extract, you might get an initial response, of course, which would be the one peak you could count, but whether there's going to be other peaks or thresholds that are going to exceed the threshold set during that 20 or 30 seconds.
Well, I think we're talking about two different things here. I think, like, counting the number of skin conductance responses over a time window, that's a valid type of analysis. But really, the first response after an image is presented, or
Yeah.
doesn't have to be an image, whatever the stimuli is, that is what we consider to be the specific skin conductance response. But if you want to bin your data into 30-second epochs, the software will go through and it will count the number of skin conductance responses, and then you can see whether the frequency of responses is changing over the duration of the experiment. And a lot of people do that, and using the epoch analysis is a great way of doing it. This measurement that I selected here, which is the event count, that can be applied to the epoch analysis. You pick your time window, you just say, let's say it's 30 seconds, and it will just record the number of skin conductance responses within that 30-second period. And if you've got half an hour's worth of data, you'll end up with 60 measurements of skin conductance values, or skin conductance count. Does that make sense?
Yeah, that's actually good. I'm glad you clarified that. So those are probably the two biggest ones that had come through. So let me share my screen one more time as we kind of follow up here. Again, I want to thank everybody for joining us. And just so you do know, today's webinar was recorded and you will receive a link to it. And we actually hold generally one or more likely two webinars every month. So we have a very large library of on-demand library of webinars that you can access at any point in time. And so if you just go to the biopac.com/webinars, you'll find that library there and can search through them. And those cover topics such as today's, which focus on data analysis and things like that, as well as different products and things to familiarize yourself with everything BIOPAC. Lastly, we do obviously have a full team of sales reps, both domestically and internationally. And so if you are interested in ever having us visit to hold a workshop for your department, your group, or even larger interdepartmental things, please feel free to reach out, contact us, and we'll be happy just to kind of talk through things with you and hopefully set something up to where we can come and present things as a person or in person, and just continue to help build your lab and support your lab. Again, always for more information, www.biopac.com. And if you have anything else we can help you with, again, on the website, if you scroll, once you're on the website, if you scroll down to the bottom of it, you will find a link there for the representative that covers your region, and so you can reach out to them directly. So again, thanks for everybody for joining us today. Thanks for Fraser for your time in presenting, and hope everybody has a great day.
Thanks everyone, appreciate it. Thanks, Tim.